Hi guys, in this video I want to look at series and parallel circuits. We will look at the differences between series and parallel circuits, voltage, current and resistance in series and parallel circuits, and find out the advantages and disadvantages of connecting components in series or in parallel. In this video I am using conventional current. Conventional current is a type of electrical current that flows from positive to negative. For more on current, check out our video titled What is Current? Let's first look at a circuit. A circuit is a path that current follows when flowing. When connecting two or more components to a circuit, we either connect them in series, in parallel, or a combination of both. In a series connection, electrical components are connected in the same path. They are connected one after the other. While in a parallel connection, electrical components are put into different paths. The circuit splits into different parts feeding different components and then combines back after the components. A combination connection involves three or more components connected such that they are components in series and in parallel in the same circuit. For example, in this circuit, resistors 1 and 2 are in the same path, while in different paths with resistor 3 and 4. Resistors 1 and 2 are in series with each other, while in parallel with resistor 3 and 4. Resistors 3 and 4 are also in series with each other. Let's look at voltage, current and resistance in series and parallel resistive circuits. When doing calculations in series and parallel resistive circuits, we use Ohm's law formula, which states that voltage is equal to the product of current and resistance. By changing the subject of the formula, current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. Just a recap, a series circuit is a circuit in which all components are connected in series, and a parallel circuit is a circuit in which all components are connected in parallel. Let's start with current in series and parallel circuits. In a series circuit, the current flowing through the components is the same. The current flowing through resistor 1 is the same as the current through resistor 2. The total circuit current is the same as the current through each resistor. This is because current is following a single path in which all components are connected. To find the current through resistor 1 or resistor 2 or the total circuit current in a series circuit, we divide the supply voltage by the sum of the resistances of all resistors, which is 1.5 volts divided by 6 ohms, we get 0.5 amps. In a parallel circuit, the current flowing through the components is different. The current splits and flows into different paths, with some flowing through resistor 1 and some through resistor 2. The current through each component depends on the resistance value of that component. To find the current through each component in a parallel circuit, we divide the supply voltage by the resistance value of that component. The current through resistor 1 is equal to 1.5 volts divided by 2 ohms, we get 0.75 amps. The current through resistor 2 is equal to 1.5 volts divided by 4 ohms, we get 0.38 amps. The total circuit current is the sum of all branch currents, or currents through all resistors in parallel, which is 0.75 amps plus 0.38 amps, we get 1.13 amps. Let's move on to voltage in series and parallel circuits. In a series circuit, the voltage used to push current through the components is different. The voltage depends on the resistance value of the component. The voltage drop or used at each component is equal to the product of the circuit current and resistance value of that component. Voltage across resistor 1 is equal to the product of 0.25 amps and 2 ohms, we get 0.5 volts. Voltage across resistor 2 is equal to the product of 0.25 amps and 4 ohms, we get 1 volt. The total voltage used in the circuit, or the supply voltage, is equal to the sum of all voltages used at every component, which is 1 volt plus 0.5 volts, we get 1.5 volts. In a parallel circuit, the voltage used to push current through the components is the same. The voltage used to push current through resistor 1 is the same as the voltage across resistor 2. The supply voltage is also equal to the voltage used at each component. This is because all components are directly connected to the energy source. They are receiving the same force of voltage. To find the voltage across each component, or the supply voltage, we do it by finding the product of current and resistance of any given resistor in parallel. In this circuit, we are given the current and resistance of resistor 2, which are 0.38 amps and 4 ohms. Then the voltage across the resistors, or the supply voltage, is equal to the product of 0.38 amps and 4 ohms. We get 1.5 volts. Let's look at the total resistance of resistors connected in series and in parallel circuits. In a series circuit, to find the total circuit resistance, we add together the resistances of all circuit components as follows. In a parallel circuit, the way of calculating the total resistance is different from a series circuit, because when adding more components to a parallel circuit, the total resistance decreases while the total current increases. We use the reciprocal formula as follows. There are advantages and disadvantages of connecting components in series or in parallel. In a series connection, if one component stops working, the other components will power off. This is because components are connected in the same path. Current is following a single path where all components are connected. So if one stops working, it causes the circuit to be open, while current flows only in a closed circuit, thus stopping current from flowing and causing other components to power off. In a parallel circuit, if one component stops working, the other components will continue working. The failure of one component in parallel does not affect other components, because components are connected to different paths. In a series connection, current flowing through a component depends on the total resistance of all components in series, while in a parallel connection, current through a component depends on its resistance. More current flows through components connected in parallel than in series. That is why the bulbs in a parallel circuit are brighter than the bulbs in a series circuit. Let's see if it is true that more current flows through components connected in parallel than in series, using resistors of the same size connected in series and in parallel. Current through each resistor in series is equal to the supply voltage divided by the sum of the resistances of all resistors, which is 8 volts divided by 4 ohms, we get 2 amps. Current through each resistor in parallel is equal to the supply voltage divided by the resistance of a resistor. That is 8 volts divided by 2 ohms, we get 4 amps. Since the current through each resistor in parallel is 4 amps and the current through each resistor in series is 2 amps, it is true that more current flows in components connected in parallel than in series. Okay guys, that is it for this video. I hope you find it helpful. Catch you in the next videos.